Welcome to SciSense, where we unwrap scientific research, because science should not be a puzzle.
Welcome to the SciSense podcast. I'm Sarah, and I'm here with Mike. Today we're talking about something that chemists are calling a once-in-a-century breakthrough. This is a paper just published in Nature by researchers at the Southern University of Science and Technology in Shenzhen, China. Mike, aluminium just did something that was supposed to be impossible.
Yeah, this one really blew my mind. So here's the deal. In chemistry, there are these special metals called transition metals, things like palladium, rhodium, and platinum. They're rare, they're expensive, but they're essential because they can do something called catalysis, which basically means they speed up chemical reactions without being used up themselves.
And why are those specific metals so good at it?
It comes down to how their atoms work. Inside every atom, electrons sit in different layers called orbitals. Transition metals have a special set of orbitals called d orbitals that are partially filled with electrons. This lets them easily gain and lose electrons, switching between what chemists call oxidation states. Think of it like a revolving door. Electrons flow in and out smoothly, and that's what drives the reactions.
So where does aluminium fit in?
Well, aluminium is the most common metal on Earth. It makes up over 8% of the planet's crust. It's in our kitchen foil, our drink cans, everywhere. But chemically, it was always seen as boring. It doesn't have those special d orbitals. It really doesn't want to switch between oxidation states. For over 100 years, every chemist agreed. Aluminium simply cannot do what transition metals do.
Until now.
Exactly. They designed a special molecular wrapper, chemists call it a ligand, that goes around the aluminium atom. This wrapper is flexible. It changes its shape as the aluminium switches between its +1 and +3 oxidation states. It essentially tricks the aluminium into behaving like a transition metal.
That's genius. So the wrapper does the heavy lifting?
Exactly. The specific molecule they created is called a carboxylyl aluminylene. I know that's a mouthful, but the important thing is what it does. The ligand adapts to support the aluminium through each step of the reaction, kind of like training wheels that adjust as you ride.
And what reaction did they actually test it on?
They demonstrated something called the Reppe cyclotrimerization. Let me break that down. You start with 3 small molecules called alkynes, and these have a special carbon-carbon triple bond, which is very strong and very useful. The aluminium catalyst stitches those 3 molecules together into a ring structure called benzene. Benzene is one of the most important molecules in all of chemistry. It's used in making drugs, plastics, dyes, you name it.
How well did it work?
Incredibly well. They got 98% yield, which means almost all of the starting material was converted to the product. It took just 2 hours, and each individual catalyst molecule performed over 2,200 reactions before it stopped working. Chemists call that the turnover number. Those numbers are competitive with the best transition metal catalysts out there.
And the cost difference is massive, right?
Night and day. Palladium cost about $30,000 per kilogram. Rhodium, which is even rarer, is about $150,000 per kilo. Aluminium, a few dollars. If aluminium can replace even a fraction of those precious metals in industrial chemistry, you're talking about billions in savings and much more reliable supply chains.
So could this change how we make medicines?
That's the dream. The pharmaceutical industry relies heavily on transition metal catalysis for making drug molecules. If aluminium can perform the same fundamental steps, what chemists call oxidative addition and reductive elimination, basically the core moves in building complex molecules, then yes, this could transform drug manufacturing. Nature, one of the top science journals, published a companion piece calling this unlocking the untapped catalytic potential of aluminium.
What a story. From wrapping sandwiches to potentially replacing platinum. Chemistry is amazing.
It really is. Main group chemistry just had its biggest moment in decades. The periodic table still has surprises for us.
Thanks for making all that chemistry so clear, Mike.
My pleasure, Sarah. Science should not be a puzzle.
Thanks for listening to SciSense. Share it with a friend. See you next time.